Okay, so I've been hearing a lot about how software is, well, fundamentally changing, maybe more profoundly than it has in decades, really.
Mm-hmm.
Feels like we're right on the edge of something, truly transformative.
Yeah.
What exactly is driving this profound shift? And I mean, how do we even begin to understand the scope of it all?
That's exactly what we're going to try and unpack today. For you listening, our mission here is to offer a really comprehensive deep dive into what people are starting to call the new eras of software development.
Oh,
We're moving beyond just, how we traditionally write programs. We're talking entirely new programming paradigms, and that's reshaping how we build applications, how we approach problem solving, and it's even challenging our definition of intelligence itself.
wow.
So yeah, this conversation, we hope, is designed to arm you with some critical insights because you need them to navigate what is undoubtedly an exciting but definitely complex new landscape.
Right. So if we really want to grasp this unprecedented shift, it sounds like we need a framework, some way to think about it. Are there distinct stages or maybe eras of software that can help us, conceptualize what's happening?
Absolutely. I think that's the best way. Think of it as three distinct stages: software 1.0, software 2.0, and now this emerging software 3.0.
So 1.0, 2.0, 3.0.
Exactly. So software 1.0, that's what most of us think of as traditional programming. You're explicitly writing code.
Mm-hmm.
We're talking C++, Python, Java, the languages that fill up GitHub. Every single line is a direct instruction from a human programmer telling the machine exactly what to do.
Like the classic way.
A classic way. A perfect example, actually, would be the early versions of Tesla's autopilot code.
Mhm.
Meticulously crafted, line by line, mostly in C++1.
Okay, that makes sense. And then something shifted, right? You mentioned software 2.0.
Mm-hmm.
What defined that, and how did it differ from that, explicit human-written code?
Yeah, that's where things started to get really fascinating. Software 2.0 moved us into the realm of neural networks.
Right.
So here, you're not writing the program instruction by instruction. Instead, you're doing something different. You're curating and tuning massive data sets, huge amounts of data, and then you use that data to train these neural networks.
Ah, okay, so the data does the work, kind of.
In a way, yes. The program itself isn't a text file of instructions anymore. It's the millions, sometimes billions, of learned weights or parameters within that neural network.
Okay.
And if GitHub is the big library for software 1.0 code, then platforms like Hugging Face have sort of become the equivalent for 2.0, a central hub to share and collaborate on these trained models.
Interesting. And you mentioned Tesla again. How did 2.0 show up there?
Well, we saw this directly with autopilot. Over time, these neural networks started to literally eat through the existing C++ code.
Eat through it.
Yeah, functions like stitching together image information from different cameras
Yeah.
or tracking objects over time. Things that were once explicit C++ instructions, they got replaced by trained neural networks. This actually led to massive deletions of traditional 1.0 code.
Wow. So, okay, we moved from writing every instruction to training systems that kind of learn their own instructions based on data. And now you're saying there's a 3.0.
Exactly.
How does that compare? What makes software 3.0 so, you said, unprecedented?
Right. This brings us to software 3.0, and this is where it gets, revolutionary, I think. Here, large language models, LLMs, they're programmed using natural language prompts. Often, yeah, plain English. Your prompts are the programs now. So instead of writing lines of Python for, let's say, sentiment classification, or even going through the whole process of training a specific neural net for it,
Right.
you just tell an LLM in plain language what you want it to do. Something like, classify this piece of text as positive or negative. That's it.
That's wild.
It is. The fact that we're now effectively programming these incredibly complex systems in our own native language is it's truly mind-blowing. It's a fundamental shift in how we interact with computers. It's like a completely new kind of computational environment.
That sounds incredibly powerful, almost like magic.
Yeah.
But does this mean, software 1.0 and 2.0 are just gone, obsolete? Why is understanding all three still so critical for someone, navigating this space right now?
That's an excellent question. And no, not at all obsolete. This is precisely why it's so important for you listening to have or develop fluency in all three paradigms.
Okay.
Each one has its own unique strengths and weaknesses. They're different tools. So depending on the specific task you're trying to solve, you'll need to fluidly transition between them.
Makes sense.
Sometimes, a precise, explicit function written in good old Software 1.0 code is absolutely the most efficient and reliable solution. Other times, maybe for pattern recognition or perception, a trained neural net from Software 2.0 is ideal. But increasingly, knowing how to effectively prompt an LLM in Software 3.0, that's going to be an absolutely crucial skill. It lets you solve problems in entirely new ways, often at unprecedented speed. So it's really about having the right tool for the right job across all three eras.
That really clarifies things, understanding these distinct eras as tools in a toolbox. But, okay, if LLMs are that fundamental, does that mean they're also reshaping the foundations, how we think about tech infrastructure itself? What kind of analogies help us understand their role beyond just being a new type of software?
That's a great pivot, actually, because yes, LLMs are definitely starting to behave less like just applications and more like fundamental infrastructure.
Okay, how so?
Well, one way to think about them is as the new utilities, like electricity or water.
Utilities, interesting.
Yeah, think about it. The major LLM developers, the ones building the big cutting-edge models, they spend massive amounts of capital, what we call CapEx, to train these models. That's like building a giant power grid, right? A huge upfront investment.
Right, the training costs are enormous.
Exactly. And then there are the operational costs, the OpEx, involved in actually serving that intelligence out to all of us via APIs, distributing the electricity, basically.
And we pay for it, like a utility bill.
Precisely. You pay for this through metered access. Often it's per million tokens processed, much like paying for electricity by the kilowatt hour.
So they're like a service we just plug into, and we expect certain guarantees, like we expect the lights to turn on.
Exactly. And just like electricity, we have very specific demands. We want low latency, high uptime, consistent quality. Reliability is key. And we've actually seen this play out when state-of-the-art LLMs go down. Even for a short time, it's like an intelligence brownout on a global scale.
Yeah, I've seen that happen. Suddenly things just stop working.
Right. The world quite literally gets dumber for a bit. And that just highlights how much reliance we're already placing on these models. It really underscores their utility-like function.
Okay, the utility analogy makes sense. And you also mentioned they share characteristics with Fabs, chip fabrication plants, because of the investment needed. Can you expand on that, even if the analogy isn't, like, perfect?
Yeah, it's not a perfect one-to-one, obviously, because software is much more malleable than, physical silicon wafers.
Right.
But the comparison to fabs really highlights the enormous capital investment required for building these state-of-the-art LLMs. We're talking billions of dollars. It points to this concept of deep tech trees, complex, layered R&D, and the centralization of immense research and development effort within these few big LLM labs.
So it's about the massive upfront R&D costs, like developing a new chip process.
Exactly. It creates this sort of centralized point of innovation for the whole ecosystem, which is quite similar to how chip manufacturing works.
Okay, utilities, fabs, those are interesting angles.
Yeah.
But what's fascinating here, and I think maybe the strongest analogy, is actually thinking of LLMs as operating systems.
Ah, okay. Tell me more about that.
Well, they aren't simple commodities like electricity, right?
Yeah.
They are becoming increasingly complex software ecosystems in themselves and the current landscape. It's shaping up very similarly to how operating systems
I
develop.
think so.
You've got a few dominant sort of closed source providers, the equivalent of, say, Windows or Mac OS. And then you have emerging open source alternatives like the whole Llama ecosystem, which could very well become the Linux of LLMs.
Interesting parallel.
Yeah, and we're still very early in this, but LLMs are becoming much more than just models that predict text. They're starting to incorporate tool use, handle multimodality images, sound, and manage really complex interactions.
So to elaborate on that, what this means for you, the listener, is pretty profound. An LLM, in essence, is becoming a new kind of computer.
The LLM itself is the computer.
Think of it this way. The LLM model acts like the CPU, the core processor. And its context window, the amount of information it can hold at one time, that's like its RAM, its memory, it's orchestrating compute resources to solve complex problems.
Yeah, I see that.
This perspective really makes it look remarkably like an operating system. I mean, think about downloading an app like Cursor, which is a dedicated LLM application for coding. You can choose to run it on different LLM providers, GPT, Claude, Gemini, much like you can run an application on Windows, Linux, or Mac OS.
Ah, right. The LLM is the underlying platform.
Exactly. You're no longer just running an application on an OS. You're effectively interacting with a new kind of foundational computational environment itself. This isn't just another tool. It's becoming the platform on which future software will likely be built. And that makes understanding its core mechanics really vital.
That's a pretty wild comparison, the OS analogy. It really shifts how I'm thinking about it. But if they're truly like a new operating system, where are we in their development cycle? Are we still kind of in the command line era, waiting for the graphical interface, the GUI?
It's almost uncanny, isn't it? We're arguably in something like a 1960s-ish era of computing right now with LLM.
The mainframe era.
Sort of, yeah. The compute required is still very expensive, and that forces the most powerful LLMs to be centralized in the cloud. So we're all essentially acting as thin clients, interacting with these big models over a network, using a time-sharing model, just like people did with early mainframes.
Right. We don't typically run the biggest models on our own laptops.
Not yet, generally. The personal computing revolution, where everyone has a powerful LLM running locally on their device, that hasn't quite happened yet. Though we are seeing early indicators like specialized Mac minis optimized for running some LLMs, showing promise for a shift towards local execution eventually.
Okay.
But for now, when you interact with an LLM directly via text, like in a chat window, it feels very much like using an operating system through a terminal. It's raw, text-based access.
Yeah, just typing commands or prompts.
Exactly. A truly general graphical user interface,
Yes.
a GUI for LLMs that works across all tasks that hasn't really been invented yet. Although specific LLM applications like the coding or search ones we mentioned are certainly starting to build out those specialized GUIs.
That's a fascinating historical parallel, the 1960s of LLMs. And what's even more unique, I've heard, is how these LLMs have actually spread. It seems to defy the usual pattern of how new technologies get adopted, doesn't it?
Oh, it absolutely does. That's another incredibly unique thing about LLMs, how they've completely flipped the usual direction of technology diffusion.
What do you mean by flipped?
Well, typically, transformative new technologies, think electricity, computing itself, the internet, they're first adopted by governments and large corporations. Why? Because they're usually immensely expensive and complex initially.
Right. Military big research labs.
Exactly. And only much later do they sort of trickle down to individual consumers. But LLMs, they're completely the opposite. They're helping you figure out how to boil an egg or solve a math problem for your kids or maybe draft an email.
Yeah, everyday stuff.
Everyday stuff. Long before they're fully integrated into, say, complex military applications or deeply embedded in massive enterprise systems, consumer adoption has happened almost instantly, overnight, reaching billions of people.
That's true. Everyone seems to be using them.
Right. This magical new computer, beamed directly to our devices, is in our hands first. And in many ways, corporations and governments are actually still playing catch-up, figuring out how to leverage them effectively. This consumer-first diffusion really informs how and where many of the first practical and impactful applications are emerging.
Okay, that's a really interesting point about the flipped adoption. So before we dive into how we actually program these things effectively, maybe we need to spend a bit more time thinking about what they actually are, as entities maybe, or perhaps their unique psychology. How do we even begin to understand these new computational forms?
That's a great question, and it's crucial. I think the best way to view LLMs, at least for now, is as stochastic simulations of people.
Stochastic simulations, like probabilistic mimics.
Sort of, yeah. They are trained on truly vast amounts of internet text and data, basically, a huge chunk of human writing and communication. And this training imbues them with an emergent psychology that feels remarkably human-like in many ways.
Emergent psychology.
Yeah, but it's important to remember it's not true consciousness or understanding as we know it.
Mm.
They are, at their core, incredibly sophisticated pattern matchers, predicting the next most probable word based on the patterns they've learned from all that human text.
Okay, so they're like echoes of human language patterns.
Yeah.
And within this psychology, they seem to possess some truly astounding capabilities, almost like superpowers, right?
That's right. They definitely have abilities that feel superhuman. For one, they have encyclopedic knowledge and memory far exceeding any single human.
Like they know everything.
Well, not everything, but an unbelievable amount. Imagine a Rain Man-like perfect recall of an immense volume of data. LLMs can easily remember things like obscure technical details, specific SHA hashes, or intricate facts from countless documents they were trained on.
Wow.
This perfect recall across vast data sets and their ability to connect disparate pieces of information in novel ways, that's truly superhuman.
So they're like walking encyclopedias with perfect recall. That sounds almost too good to be true.
Mm.
There must be downsides, right? What are their limitations? What are the cognitive deficits that come along with these superpowers?
It's absolutely critical to understand these deficits.
Right.
Because despite those incredible powers, LLMs also have significant cognitive flaws that you really need to be aware of when you're working with them.
Okay, like what?
Well, first, they hallucinate. Quite a bit, actually. They can simply make stuff up, but state it with absolute confidence.
Right. Confidently wrong.
Exactly. They lack a perfect internal model of self-knowledge, although this is gradually improving with newer models. Second, they display what people often call jagged intelligence.
Jagged intelligence.
Yeah, meaning they can be superhuman in some really complex problem-solving domains like advanced programming or maybe legal analysis, yet make basic, almost absurd errors that no human would ever make.
Any examples?
Sure, like insisting that the number 9.11 is greater than 9.9 just because 11 is bigger than 9. Or, famously, sometimes struggling to spell simple words like strawberry, even while generating complex code. These are real rough edges that can easily trip you up if you're not careful.
That's quite a list of limitations, especially compared to the superpowers you mentioned. How do you reconcile that? Is it just that it's early days, or are these sort of fundamental characteristics we'll always have to work around? And what about memory? Humans learn and consolidate knowledge over time. Do LLMs do that?
That's a key tension, yeah, working with them. And on the memory front, that's another significant deficit. They suffer from something kind of like anterograde amnesia.
Like in the movies.
Exactly. Unlike humans, who naturally consolidate knowledge and gain expertise through experience over time, LLMs don't natively do this. Their context windows, that working memory we talked about, need constant reprogramming for each interaction.
So they start fresh each time, more or less.
Pretty much. Think of movies like Memento or maybe 50 First Dates, where the protagonist's memories reset each day or after a short period. That's largely how an LLM operates by default. Its core underlying knowledge, the weights, are generally fixed after training, and its context window is effectively wiped clean after each session, meaning it doesn't gain continuous expertise or learn from past mistakes on its own over long periods without specific techniques to manage that context.
Okay, so they don't learn from interaction in the way we do. They don't consolidate experience automatically. And what about security implications? You mentioned their gullibility earlier.
Right. They don't have that persistent, evolving self-knowledge or memory consolidation. And yes, absolutely, there are important security limitations to be aware of. LLMs can be quite gullible. They're susceptible to prompt injection risks, where malicious instructions hidden within a prompt can trick them into overriding their intended behavior or revealing information they shouldn't.
Yeah.
And they also pose potential data leakage risks if users inadvertently enter sensitive personal or proprietary information into the chat or prompt. So what does all this mean for you, the user or developer?
Yeah, what's the takeaway?
It means you absolutely need to program them or interact with them by carefully understanding and actively working around these specific deficits. That's how you get to fully leverage their incredible superhuman powers. It's all about designing your interactions to account for their unique mix of strengths and weaknesses.
Okay, so given these really unique characteristics, the superhuman stuff, alongside these frankly, kind of strange cognitive deficits, some might question their immediate utility, right?
Yeah.
You're suggesting there are actually immense opportunities precisely because of this unique psychology. Where are the biggest openings right now?
You're right to ask, and yes, absolutely. The biggest opportunities, I think, lie in what we can call partial autonomy apps.
Partial autonomy apps, okay.
Yeah. This is exactly why using a dedicated LLM application, something like Cursor for coding or maybe Perplexity for search, is often far more effective, far more useful than just interacting directly with a raw LLM like ChatGPT in a blank chat window.
Why is that?
Because these apps are specifically designed to do two things: work around those deficits we just discussed and really amplify the superpowers.
Okay, so what are the key properties then?
Yeah.
What makes these specialized LLM apps indispensable, or at least better than just the raw chat interface?
Well, these LLM apps typically have several key properties. First, they handle a ton of the context management for you. They figure out how to feed the LLM the right information from your project or your documents at the right time, so you don't have to manually copy and paste everything constantly.
That's
It really is. Second, they often orchestrate multiple calls to different LLMs under the hood. So for instance, a coding app might use one LLM for creating embeddings, those numerical representations of code, another LLM for the conversational chat part, and maybe yet another specialized model to actually apply the suggested code changes, the diffs.
Ah, so it's not just one model doing everything.
Often not, no. Third, and this is critical, they provide an application-specific GUI, a graphical user
Right,
interface.
the visual part.
Exactly. You generally don't want to just talk to a raw text-based operating system all day long, right? Visual interfaces, like seeing code changes highlighted in red and green, or seeing clear visual source citations for search results, they make it far easier and faster for you, the human, to audit and verify what the potentially fallible system is producing.
Makes sense. Faster to check.
Yeah, GUIs are truly a highway to your brain. They make that verification step much more intuitive. And lastly, these apps usually feature what you could call an autonomy slider.
An autonomy slider.
Yeah, you, the user, get to control the level of AI involvement. It can range from small questions like simple task completion in a coding editor, all the way up to more agentic actions, like letting the AI refactor an entire file or even make changes across a whole repository. This lets you tune the amount of autonomy based on the task's complexity and, frankly, your own comfort level.
Okay, so it sounds like the core dynamic here really is human-AI cooperation. The AI generates something, and the human verifies it. How do we make that loop as fast and efficient as possible? Because that seems key.
That's absolutely the crucial dynamic, exactly. The AI generates, you verify. And the entire goal, the focus of building good LLM apps, is to make this generation verification loop as fast as humanly possible.
Yeah.
And that means speeding up your ability to verify, which is precisely where those custom GUIs and visual representations become so incredibly important. Reading a long, dense block of generated text is effortful and slow. Glancing at a clear, well-formatted code diff or a visually structured source citation is much more intuitive and fast.
And I imagine keeping the AI on a leash, as you put it, is pretty vital too,
Yeah.
especially given those jagged intelligence issues and hallucinations you mentioned earlier. We don't want, like, a 10,000-line code change that we can't possibly review properly.
Absolutely. Keeping the AI on a leash is paramount right now. It's just not useful, maybe even dangerous, to get a massive 10,000-line code diff that
Yeah.
you then have to spend days painstakingly checking for subtle bugs or security vulnerabilities.
Right, that defeats the purpose.
Totally. We need to work in smaller, more incremental chunks. Give concrete, specific prompts to ensure the AI stays focused on the task at hand and doesn't get, lost in the woods generating something unmanageable or incorrect.
Can you give an example?
Sure. Think about education. An AI can certainly help create course content, right? But it's probably best kept on that leash by defining a very clear syllabus first or outlining a step-by-step project progression. This helps ensure the generated content remains auditable, accurate, and consistent with the learning goals, rather than just rambling off topic.
Okay, that makes sense. This whole dynamic, the promise versus the current reality, it reminds me a bit of the early excitement around self-driving cars, where the promise felt so close, maybe a decade ago, but the reality of achieving true, full autonomy has proven far more complex and taken much longer. Is that a fair comparison for where we are with AI agents today?
Oh, it's a very fair comparison, I think, and one I think about quite often. I vividly remember back in maybe 2013 experiencing a perfect, 30-minute self-driven ride in an early autonomous vehicle prototype with zero human interventions needed.
Wow, back then.
Yeah, it truly felt like full autonomy was imminent, just around the corner, yet here we are over a decade later, and while we definitely have impressive driverless cars operating in certain restricted zones, there's still a significant amount of remote teleoperation and human oversight involved behind the scenes. It's not fully solved everywhere.
Right, it's taking time.
Exactly. So when people start talking about the year of agents as if immediate widespread full autonomy for complex tasks is here or now, I get a little bit concerned. Based on the self-driving experience, this seems much more likely to be the decade of agents. It's going to take time, iteration, and we absolutely need humans firmly in the loop for the foreseeable future for most meaningful tasks.
So following that thought, It's maybe less about building fully autonomous robots right away
Mm.
and more about creating tools that augment human capabilities. The Iron Man suit analogy comes up a lot here. Does that fit?
Precisely. I think the Iron Man suit analogy is perfect for where we are and where we should be focusing right now. We're primarily building augmentation tools, tools that enhance humans, making us faster, smarter, more capable, rather than trying to build fully autonomous robots that operate completely independently without oversight.
Okay.
So the products that are likely to succeed in the near term will probably feature those custom GUIs we talked about and meticulously designed UI/UX, all aimed at speeding up that human generation verification loop.
Making the human superpowered.
Exactly, making you, the human, superhuman.
Mhm.
And they'll also have that autonomy slider we mentioned, which can be gradually expanded, pushed further out in the future as the underlying AI technology matures, and crucially, as our trust in it grows based on proven reliability.
Right. And this focus on augmentation and the natural language interface, it brings us to this really unprecedented idea you touched on, vibe coding.
Yeah.
Because LLMs are programmed with natural language, it sounds like suddenly everyone can be a programmer.
Yeah.
That feels like a huge shift in accessibility.
It really is. It's potentially massive. You might no longer need, say, 5 to 10 years of dedicated study and practice in traditional coding languages to build something functional, maybe even useful.
Wow.
You can start building custom applications or simple automations just by describing what you want in plain language. I've seen incredible examples of this already, even kids building small games or tools. It's truly wholesome in a way. It's like a gateway drug to software development.
Uh-huh. A gateway drug.
Yeah, it's inviting people who never, ever consider themselves programmers into the fold. I mean, personally, I even vibe coded a basic iOS app in Swift, a language I absolutely do not know, and actually got it running on my phone in a single day just by telling the LLM what to do step by step.
That's amazing.
And I also created this little web app called Menugan. It takes a picture of a restaurant menu, identifies the items, and then uses an image generation model to create pictures for each menu item, all just by describing the workflow I wanted to the LLM.
Okay, that sounds almost
Hmm.
too easy. So
Yeah.
what's the catch? If the code itself is becoming so accessible through vibe coding, what's the hard part now?
That's the surprising paradox, isn't it? The code itself, generating the core logic and functionality, is often astonishingly easy now, sometimes taking just minutes or hours. The really challenging part, the stuff that still takes days or weeks, is often the making it real aspects. Things like setting up user authentication, handling payments securely, configuring domain names, managing databases, and actually deploying the application so other people can use it. All that DevOps stuff.
The plumbing.
Exactly, the plumbing. It still involves a huge amount of tedious manual clicking through various web interfaces, navigating complex configuration menus on AWS or Google Cloud or wherever. And LLMs currently aren't very good at reliably automating that kind of visual, click-based interaction. It's genuinely frustrating to get the core app functionality working beautifully in a few hours and then spend a week just clicking through setup instructions.
Yeah, I could see that.
And it really highlights a clear need.
Yeah.
We need to start building our digital infrastructure specifically for these new kinds of digital consumers, the AI agents themselves.
Okay, this raises a really important question then. If agents are becoming a new type of digital consumer, maybe even the primary consumer of APIs in the future, how do we build our online infrastructure for them? What changes need to happen on the web itself to make it more LLM-friendly?
It's a critical shift in thinking that needs to happen. Just like websites historically started using a file called robots.txt to give instructions to traditional web crawlers like Googlebot.
Right, telling them what they can and can't crawl.
Exactly. We might start seeing something similar emerge, maybe like an LLM.txt file, a simple, standardized markdown file that clearly tells visiting LLMs about a domain, what it is, what its purpose is, how its APIs work, maybe rate limits, making it far easier for them to understand and interact correctly, rather than trying to parse complex, messy, human-centric HTML designed for eyeballs.
That makes sense, like a manifest file for agents. And beyond just telling them what a site is, what about how to actually interact with it? You mentioned the problem with clicking buttons. A huge amount of existing documentation is written for humans, with visual cues like click this button here. That's not directly accessible to an LLM, is it?
No, exactly. That human-centric documentation full of screenshots and click here instructions is a major barrier for automation by agents. But the good news is we're already seeing a crucial transition starting to happen.
Oh yeah, Where?
Some really forward-thinking services like Vercel for deployment or Stripe for payments, they're already transitioning their core developer documentation primarily to Markdown format.
Which is easier for LLMs to read.
Super easy for elements to understand and process. It's just structured text. But more importantly, they're even starting to replace instructions like click here to create an API key with the direct curl command or an API call snippet that an LLM agent can copy and execute directly.
Giving the agent the actual command.
Precisely. This shift from human-readable instructions to machine-executable instructions and documentation is absolutely crucial for unlocking a massive amount of automated, agentic use of online services in the future.
So it really all boils down to meeting LLMs halfway, doesn't it? Making it easier for them to consume and process the information and instructions they need.
That's the essence of it, yes. Even if LLMs eventually get really good at navigating and clicking around complex web interfaces, which is a hard problem, it's still going to be far more efficient, far more reliable, and almost certainly less expensive in terms of compute costs to just provide them with easily digestible, structured information up front.
Feed them the data they need directly.
Exactly. And we're already seeing tools emerge to help with this. Things like Gettingist for GitHub repositories, which basically just concatenates all the code files in a repo into a single big text document, ready to be copied directly into an LLM's context window for analysis.
Simple but effective.
Yeah. Or slightly more advanced tools like DeepWiki, which goes even further. It actually uses an LLM to analyze a code repository and then automatically build structured LLM-friendly documentation for that repository.
Well, using LLMs to make things easier for other LLMs.
Exactly. These tools are all about transforming human-readable content into LLM-friendly formats for easier consumption and analysis. This kind of mutual adaptation, where we make our systems easier for AIs to understand and AIs get better at understanding them, that will be absolutely key to unlocking the full potential of these new software paradigms.
Okay, so to try and summarize this incredible landscape that you, our listener, are now entering, software is fundamentally changing, perhaps more profoundly than it has in, 70 years.
It feels that way, yeah.
These large language models are not just new kind of software. They're starting to act as new operating systems, albeit maybe in their 1960s era stage, still largely centralized, accessed primarily via time-sharing through the cloud.
The OS analogy holds up well, I think.
And perhaps most importantly, we're all learning how to work with their unique psychology, navigating their incredible superhuman powers, alongside their significant, sometimes baffling, cognitive deficits.
It's a new skill set, for sure.
So the immediate future, it seems, is really about building these partial autonomy products. Products that keep humans firmly in the loop, focusing on speeding up that critical human generation verification cycle, and ultimately making software creation dramatically more accessible to potentially everyone through things like vibe coding.
Yeah, I think that sums it up really well. And if we connect this to the bigger picture, that Iron Man suit analogy, I think it beautifully encapsulates the likely trajectory for the next decade.
A gradual enhancement.
Exactly. A gradual shift of that autonomy slider, bit by bit, transforming how we work, how we create, how we interact with information. It's fundamentally about augmentation and enhancing human capabilities in ways we're probably just beginning to imagine. So the question for you, listening, is what will you build? What will you create when the main barrier to creating powerful software is just being able to clearly talk to a computer?
A provocative thought to end on.
We really encourage you to reflect on your own role, your own potential in this genuinely exciting and rapidly evolving new era of technology.